In this episode, we're going to make a very Linux kind of idea feel practical and calm. The idea that you can control running work without rebooting, without panic, and without guessing. When a program is stuck, when a command takes longer than expected, or when a terminal feels frozen, beginners often feel like the only option is to close the window and hope nothing important breaks. Linux gives you a more disciplined set of controls through signals and job control, which are two closely related ways of steering processes while they are running. Signals are messages the operating system can deliver to a process, and job control is the shell's way of helping you manage which processes are attached to your terminal right now. These concepts matter on Linux Plus because they show up in troubleshooting and operation scenarios where the right move is to pause, resume, or stop something safely rather than to brute force it. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good starting point is to remember that a process is a running program instance identified by a process identifier, PID, and the kernel is the authority that decides when it runs and how it receives events. Processes are not isolated islands because they interact with the system and with each other through resources like files, network sockets, and the terminal. Signals exist because the system needs a standard way to notify processes that something important happened, such as an interrupt request, a termination request, or a request to pause. Think of a signal as a knock on the door of a process that says respond to this condition now, and the response can be default behavior or custom behavior depending on the program. This is where beginners often get confused because they expect signals to always mean forceful destruction, but many signals are simply requests to change state. When you understand that signals are a communication mechanism rather than a single action, you can choose gentler options first. The words stop, continue, and kill in the title describe three of the most important outcomes you can cause with signals, but it helps to separate the outcome from the method. Stopping a process means pausing it so it does not execute instructions, which can be useful when it is misbehaving but you are not ready to end it. Continuing a process means allowing a previously stopped process to resume execution, often from the exact point where it paused. Killing a process means terminating it, but even then you can terminate it gently or forcefully depending on the signal you choose and how the process responds. A beginner misunderstanding is thinking that kill always means forceful destruction, when kill is really a historical name for sending a signal, and some signals are polite requests. Linux Plus questions often reward the student who recognizes that termination can be staged from graceful to forceful. To reason about this cleanly, imagine you are supervising a worker doing a task. A stop signal is like asking the worker to pause and wait without leaving the room, keeping their work in memory and ready to resume. A continue signal is like telling the worker they can start again after being paused. A gentle terminate signal is like asking the worker to wrap up and leave, giving them a chance to save state, close files, and clean up. A forceful terminate signal is like removing the worker instantly, which may be necessary in emergencies but can leave the environment messy, such as leaving temporary files behind or leaving partially written data. That analogy is helpful because it reminds you that safe system management often means choosing the least disruptive intervention that solves the problem. On an exam, if a scenario hints that data integrity matters, the expected reasoning usually favors graceful termination before force. Now let's connect signals to the terminal experience, because job control is mostly about the relationship between processes and the terminal session you're using. Your terminal is typically connected to a controlling terminal device, historically described as a teletypewriter, TTY, and the shell running in that terminal can manage jobs that it started. A job, in this sense, is a process or a pipeline of processes that the shell is tracking as a unit. The shell can attach one job to the foreground, meaning it owns the terminal for input and output, while other jobs can run in the background, meaning they can keep executing without owning your attention. Beginners often think background means less important, but background simply means not attached to the keyboard right now. This matters because a program can appear to freeze your terminal when it is in the foreground and waiting, even though the system is fine, and job control gives you a way to regain control without destroying the process. Foreground and background decisions are really about attention and interaction. A foreground job can read from standard input, write to the screen, and receive certain control events from the terminal in an immediate way. A background job can still compute and still write output, but it is not in a position to interact with you as directly, and many programs behave differently when they are not connected to an interactive terminal. This is why moving a job to the background can be helpful for long-running tasks that you do not need to babysit, while keeping a job in the foreground is appropriate for interactive programs that need your responses. Linux Plus questions sometimes describe a user launching something that takes a long time and wanting the terminal back, and the correct mental move is to think in terms of job control rather than system failure. If you understand that the shell can detach work from the foreground, you can answer those scenarios confidently. Stopping is the bridge between job control and signals, because the shell can arrange for a foreground job to be stopped, which makes it neither running in the foreground nor running in the background. A stopped job holds its state, which means its memory and progress remain, but it is not consuming CPU time because it is paused. This is an extremely useful intermediate state when you want to temporarily halt something, perhaps because it is producing too much output, using too many resources, or waiting for an input you are not ready to provide. Beginners sometimes terminate tasks simply because they want to regain the prompt, but stopping allows you to regain the prompt while preserving the option to continue later. That can be safer than termination when you are unsure whether the process has important unsaved work. On the exam, if a scenario suggests you want to pause work and resume later, stopping is the concept to recognize. Continuing, in turn, is the controlled way to resume a stopped job, either by bringing it back to the foreground or by letting it run in the background. The important beginner idea is that continue is not restarting the program from scratch. It is allowing it to proceed from where it left off. That means continuing is often a faster and safer move than rerunning a long task, especially if the task took significant time to reach its current point. It also means you must consider whether the job still has the environment it needs, such as access to certain files or a stable working directory, because the process state is preserved, but the external world may have changed. A job that was paused while holding a file open will still hold that file open, which can be useful or problematic depending on what you do next. Linux Plus questions sometimes imply that a paused job is blocking something, and the right reasoning is to recognize that the job's preserved state can still affect the system even while paused. Now we can tackle kill in the mature way Linux expects you to think about it, which is as a spectrum of termination choices rather than a single action. A gentle termination request asks the process to exit in an orderly way, giving it a chance to close files, flush buffers, remove temporary artifacts, and write final logs. Many well-written programs treat this signal as an opportunity to clean up, which reduces the risk of data corruption and reduces the chance of leaving behind confusing leftovers. A forceful termination, by contrast, ends the process immediately, which can be necessary when a process is truly hung or unresponsive, but it can also leave the system in a messy state. The exam often tests this by describing a process that is not responding and asking what kind of termination is appropriate, and the best reasoning is usually to attempt graceful termination first and escalate only if needed. This mirrors real-world operational discipline and shows you understand consequences rather than just mechanics. A key gotcha for beginners is that killing the wrong thing can create much bigger problems than letting a slow task run, and that's why identity checking matters before termination. Many systems run multiple processes with similar names, and some processes are parents of other processes, so terminating a parent can cause a chain reaction. There is also a difference between a user-launched job in your terminal and a critical system service, and the consequences of termination differ dramatically. This is why process context matters, including the user identity that owns the process and the role the process plays. It's also why job control can be safer than kill when your main issue is terminal control, because stopping or backgrounding changes how you interact with the process without ending it. Linux Plus questions sometimes include this nuance by describing a service outage caused by terminating the wrong process. And the lesson is that you should understand what you are controlling before you control it. Signals are powerful, so careful targeting is part of the skill. Another important beginner misunderstanding is expecting signals to behave the same way for every program, when the reality is that programs can handle some signals in custom ways. Some signals can be caught and handled, which means the program can decide to ignore them, delay them, or perform cleanup steps before exiting. Other signals cannot be ignored, which is why they are the last resort when a process refuses to stop. This distinction matters because it explains why a polite termination request might appear to do nothing at first, even though the program is actually shutting down gracefully by finishing a critical operation before exiting. It also explains why a forceful termination can end a process that is otherwise ignoring or delaying other signals. The practical lesson is to interpret outcomes as evidence. If a process responds to a gentle request, that is ideal, and if it does not, you escalate carefully. Linux Plus questions often test this by describing a process that does not stop when asked politely, hinting that a stronger signal might be required. Job control also introduces a useful concept about the relationship between a process and its input, because many interactive programs assume they will be in the foreground and will be able to read from standard input. When such a program is put into the background, it may not be able to read input safely, and the shell may prevent it from doing so to avoid confusion and terminal corruption. This behavior can surprise beginners, because they expect background to mean run normally without bothering me. But some tasks are inherently interactive and do not make sense without foreground control. The practical decision is to background tasks that are non-interactive and long-running, while keeping interactive tasks in the foreground or stopping them when you need to shift attention temporarily. This also helps you interpret exam scenarios where a user backgrounds something and then it behaves oddly, because the correct explanation may be that the program requires foreground interaction. Understanding the terminal as a shared resource clarifies why foreground and background are meaningful states, not cosmetic labels. Signals are also deeply connected to system stability because they provide a way to recover from stuck states without rebooting, but they must be used with awareness of data and resource integrity. A process might be holding a lock, writing to a file, or managing a network connection, and terminating it abruptly can leave partial work that other processes must handle. This is why graceful termination is preferred when possible and why stopping can be a useful diagnostic step, because you can pause a process to reduce its impact while you investigate what it is doing. Stopping does not fix the underlying issue, but it can buy you time and reduce collateral damage if the process is overwhelming the system. The exam may not ask you to conduct deep incident response, but it does ask you to choose safe operational decisions, and signals are a big part of that. When you treat signals as a toolbox for controlled intervention, you naturally choose options that preserve system integrity. A practical way to tie everything together is to think of a calm decision sequence for common situations, because that prevents you from leaping straight to force. If your terminal is busy because a foreground task is taking too long, your first decision is whether the task should keep running. If yes, you might want it in the background so you can do other work. If you want to pause it temporarily, stopping is often the safest intermediate state because it preserves progress while giving you control back. If the task must end, you prefer a graceful termination so it can clean up, and you escalate to force only if it refuses to respond. If the issue is broader system slowness, you focus on identifying the process and understanding its role before terminating anything, because the highest resource consumer might be doing legitimate work. This is not about memorizing exact keystrokes or command spellings. It is about applying the same disciplined reasoning every time. Linux Plus questions are usually testing this reasoning pattern, even when they dress it up in scenario language. By the end of this episode, you should feel like stop, continue, kill, and foreground and background decisions are not random tricks, but coherent tools built on the consistent way Linux manages processes. Signals are messages delivered to processes, and they can request termination, request pausing, or request continuation, with different levels of force and different program behaviors. Job control is the shell's way of helping you manage which work owns your terminal and which work can proceed without your constant attention, with the controlling terminal and TTY relationship shaping what is safe. The safe habit is to choose the least disruptive control that meets your goal, to verify you are targeting the correct process identity, and to escalate from gentle to forceful only when necessary. When you can explain these choices in plain language, you can answer Linux Plus questions confidently because you are reasoning from system behavior and consequences, not from guesswork. You also gain a real-life skill that makes Linux feel manageable because you can steer running work rather than being trapped by it.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.